A lot of things we think about during the day. For example, when will this pandemic end? Why did The Office leave Netflix? But of course, when we're all thinking about what would happen to a car's velocity when you change its weight. I would use an actual car, but because I'm not legally allowed to drive by myself, I got the next best thing. Toy cars. I have two cars right here. This red one weighing 33 grams, and then this black one with poorly duct tape weight on top of it weighing 57.5 grams all together. If we put them on the state-of-the-art ramp at the exact same time, which one will basically hit the bottom of the wooden part first? And answer that. You will see that the black one with the weight on it actually just gets there just a tiny bit faster than the red one. And to really solve how much faster it is going, I have to do that more mathematically. Okay, so basically this is the entire mathematical part of all the stuff that I just showed. Sorry about the whole cat thing. But basically, we have which way is positive, which is down and to the right. We have the picture right here, and I decided to use motion equations because Logger Pro just didn't want to work. It was frustrating me, and I was just tired of it, so I just went to motion equations. And the red car's on this side, the black car's on this side. We have all the data right here, followed by the equation, which is displacement equals initial velocity plus velocity over 2, and then time. Plug in all those numbers, you get x. Do the same thing for y. X right here, y is right here. Use the Pythagorean theorem to get like the final velocity of x and y. And then we did the same thing for the black car, the same data points and all of that. Same plug-in and same exact equation, except instead of using 1.19 seconds, I used 1.16 seconds. I got the time by running each car down the ramp that I had earlier in the video 10 times and taking the average time it took to get there, which is the different weight caused the different time, which ultimately caused the velocity to be bigger at the end, as you can see down here, as 1.40102 meters per second is less than 1.43725 meters per second, and the second one being the black car, which again weighed more than the red car. All right, so at the end of the day, this really just leads to one question after everything I just showed you. Why should you care about everything I just told you? And one like real life example I can really think of at the top of my head is during the Winter Olympics, and it was supposed to happen, but because, Corona, it didn't. But whenever it does happen again, for example, whenever like snowboarding or skiing or any like Olympic event that requires some kind of like object or person going down that slope, kind of like how the cars went down the little ramp there, the heavier objects will go faster, so the heavier skiers will go faster, which is obviously what you want because it's a timed event. So that is like the main way I can think of why all this really matters.